All right, here for AP Physics Linear Motion, problem 6, which says a particle moves along the x-axis. Its motion is described by this equation. Position is a function of time, meters and seconds. Determine the velocity at the instant it changes direction, and its velocity when it returns to the position it had at time 0. So, going to be just kind of a quick application of calculus here actually involved. But even before that, just this concept. All right, the velocity at the instant it changes direction. You can say, well, the instant it changes direction, that would be at the point where it's going from, the way we describe directions with velocities is either positive direction or negative direction. Positive velocities mean I'm going the positive direction, and negative velocity means I'm going the negative direction. So I really, when it changes direction, that's when I'm switching from positive to negative or negative to positive. And to do that, to go from positive numbers to negative numbers, or vice versa, you have to pass through 0. And that's it. When you change direction, your velocity is 0. And so what I really just need to do is, well, that's it. I mean, that's basically it, all right? Got to pass through 0 to go from positive to negative or negative to positive. So the velocity is going to be 0 at the instant it changes direction, all right? So on the paper, I might say something to that extent. Problem 6, part A. Since the sign of velocity indicates direction, it has to switch signs when direction changes. And to switch signs, that's positive or negative, the velocity has to pass through 0. And so that is the velocity when you switch directions. It's going to be 0. If I want to talk about it like from a, VT graph sort of thing, then you say, hey, when I go from negative velocities to positive velocities or positive to negative, I'm going to have to pass through 0 at those points where I'm switching directions from negative direction to positive direction or positive to negative. And so that's it. The velocity is 0 at the point where I switch directions. If you want to talk about, yes, let's just leave it at that. Okay. Yeah, let's go to part B. Okay, so part B of problem 6 says, okay, can you find the velocity when it returns to the position it had at time 0? So maybe I'll take a look at my position equation, which is that position is 2 plus 3t minus 4t squared. And you say, okay, well, I want to know the velocity when it gets to the position it had at time 0. What was the position at time 0? I can just substitute in a 0 to find that initial position. So if I substitute in zeros, you can see that all that's going to be left is x equals 2. So my initial position is 2 meters. All right. I want to know what's the velocity when it gets back to 2 meters. So at some later time, this equation is going to give me x equals 2, right? And you say, well, basically then I just have to solve for the time that will make this term be 0. So I get x equals 2 again. So what I'm looking at here is making it so that 3t minus 4t squared is equal to 0. Well, if I factor a t out, t times 3 minus 4t, right? That would factor out the t. Either this is 0, I'm multiplying these two things by each other, either this is 0 or this chunk is 0, right? Well, when this is 0, that's times 0. That's this initial condition. So I need the value of t that makes this 0. Well, that'll be when t is 3/4 seconds. That's the other time when velocity would, when the position would be 0, or would be 2 meters, I mean, when it's equal to the initial position, right? This term would drop out, be 0. So that's it. So I need times 3/4 seconds. Okay, that's the time when it returns. I want the velocity when it returns. So to do that, I'm just going to get my velocity equation. And to do that, I'll take a derivative. I'll say velocity is the derivative of position with respect to time, right? And so that would be the d dt of the position equation, 2 plus 3t minus 4t squared. Okay, and we can do that derivative pretty straightforward here. Derivative of a constant term is 0. Derivative of 3t would be 3. Derivative of minus 4t squared, the t squared would become 2t to the first. 2 times negative 4 is negative 8t. So this is my velocity equation. I want to know the velocity when it returns to the initial position. It returns to the initial position at 3/4 seconds. So let's put that in there for t and find out what the velocity is. So velocity would be 3 minus 8 times that 3/4 we figured out. 3/4 of 8 is 6. 3 minus 6, the velocity at 3/4 seconds is going to be 3 minus 6, negative 3 meters per second, right? Which is what they were asking for. All right, that's problem 6.